Oh, goodness. Good morning, good afternoon, good evening, wherever you may be hailing from. This is Red Hat Enterprise Linux Presents episode number 78. Today, we are going to take our first look at image mode for RHEL. And I have to admit that if I wanted this episode, I had to agree to the new bumper. To explain why, I've got a couple of my favorite people in the RHEL business unit here today to talk about image mode and music. So why don't I go ahead and bring in our guests for today, and we'll dive in. So Ben, I'm calling you out here. You
Yeah.
got star glasses, and and uh, and you're the demo king for today. So why don't you introduce yourself? Tell us what you do for fun.
I don't know. Matt might be the demo king. I guess the viewers will decide. Yeah. Hey. So Ben Breard, product management here at Red Hat. I don't always wear really cool sunglasses, but when I do, it's for Red Hat. Yeah, product manager, and I've been working on everything here we're going to talk about as far as image mode for RHEL, which we think is great, and we all felt strongly enough that it needed some better intro music. So yeah, I hope you guys enjoyed it.
I know I did. So Ben, on top of being in IT, you also have an interest in music and apparently video editing now. So, any particular instrument or style of music that you find yourself leaning towards the most?
Oh, I play classical, jazz, rock, heavy metal, as you heard. Yeah, you name it, I struggle at it. Mostly, yeah, guitar, and the addiction is all over here. Yeah.
And then, so Ben is this is what like your third RHEL presents, but Mr. Matt Micene, you are new to RHEL presents, but not new to our team. So why don't you introduce yourself and tell us what you do here at Red Hat and what you do for fun?
Yeah, what do I do here at Red Hat? I've done a few things,
What
but
don't
most
you do? Maybe
recently,
more accurate.
yeah, that's a little on the true side. But most recently, I have rejoined y'all's team on the TMM side of the house to mostly because of Ben. This is Ben's fault. The idea here that we got going on with image mode really sparked a lot of stuff that we've been working on a decade ago with Project Atomic and some other things. So it felt like a good time to come back and join the fold of TMMs and bring the good word of image mode to the people.
Awesome. Um, any hobbies you feel like are worth a mention?
I buy a lot of Ben's used gear and then make even worse noises with it. Um, yeah, I think that the most recent one was a lovely little, very cheap acquisition from Ben of a wah pedal that I have made the 1977 chunka chunka sound, and that's about it. I still have yet to figure out how to make that work well. But yeah, I also recently picked up trying to manipulate the actual physical body of the instruments themselves. I picked up a couple of kits and have been working on hand carving different shapes out of them from their standards and trying to figure out how they actually function and if I can do anything with that.
Nice. Well, why don't we dive into the meat of today's conversation? And image mode is what brought us all together for this episode. And of course, Ben brings his own flair of star shaped classes, which I guess was kind of a inside joke from Summit. But
Should we explain the joke? We should explain it, right?
I feel like it deserves explanation.
Yeah. Uh, yeah. So the main command you're going to use to interact with image mode is called bootc. Bootc was written by one of our coworkers who's brilliant. His name is Colin. And if you're a music fan, which of course Matt and I are, and you know the funky wah stuff he was talking about, if you heard of Parliament, they have one of the funkiest bass players in the world. His name is Bootsy Collins, and he of course always wears star-shaped glasses. So to help people remember and everything, we've been having some fun with these glasses. And I think I'm going to take them off because it's making me crazy.
I can actually see now.
But yeah. So yeah.
And so we've kind of beat around the topic. what is image mode, and what's all the hubbub been about since Red Hat Summit?
Yeah. So basically, we've made RHEL is easy to build, ship, run as container images. So at a high level, all of the tooling, the process, everything that you do on the application side of the house, you can take and use that to build operating system images. So we actually gain a huge amount of efficiencies, and a bunch of operational benefits. There's a slew of benefits you get from doing that. But that's the core essence here is we can now use container files, container tools, registries, everything that we know for both applications and operating systems.
So one of the advantages would be configuring and building your operating system the exact same way that you would use a pipeline to build a container image.
Yeah, yeah, exactly. And so, think about if I look back over 10 years, right? The explosion and just the tooling, the automation, the efficiencies, all the gains that we've seen from cloud native infrastructure, and how that's really hit the app side of the house maybe harder than like the core Linux processes probably haven't really changed that much from an administrative side. It's amazing to think that like a lot of these pipelines and stuff that are in place, we can apply that same type of testing, gating, and automation just at the Linux OS. So, and actually the amount of testing, like I'll give you here's one example. A lot of people, they patch and pray. Now the patches we make are really good and it works a lot. Like I do this for my personal systems, right? But when the stakes are high, that's maybe not the best strategy. But think about it this way: with if you're now using container tooling to build your OS image, you can literally boot the container, but you can also run it as just a container. And so now actually CI is much easier, much faster, much less expensive at the OS level than it's ever been before. That is super powerful. So there's I mean, we can go on and on with this stuff, but that's kind of my take on it.
One of the things we've talked a lot about on this show is, say, image builder or using tools like Cloud Init. But Matt, I imagine that that image mode is going to make it easier to distribute images.
Yeah. So one of the things that using, like Ben said, right, the standard container tooling that we've got everywhere else means that we also have the ability to use registries to store and forward, right, along with all the things you get with that, like versioning and manifest inspection, and whatever security tools that you've got available to inspect container tools the same way you would have if it were a host, right? So one of the things that all of the sort of the things we're doing, even when we get around to images today, we don't have a really good way of cataloging and containing and understanding, okay, this is the source that we're going to be running in Amazon and we're going to run in our data centers. If we do have them, they're kind of limited and they're only for that particular environment, right? So one of the nice things about this workflow is getting that access to sort of a central repository that you can run from anywhere to anywhere, and you have very precise ideas of when things were changed, where things are going, and how you can control those for access in different ways.
So I want to skip ahead just a little bit here. I know we spent a lot of time putting an episode guide together, but I'm throwing that away, at least for a moment. A lot of this sounds great conceptually, but how does this work? Why don't we dive in and show kind of proof of life of what this looks like? Matt, I think you were up first.
Yeah, I can do proof of life. So like we said, this is a pretty standard container build, right? So I'm just going to go ahead and run one real quick, and I'm going to go ahead and tag it so that we can push it to Quay, right? We talked about, I just mentioned, centralized repositories, as I can try to type and talk at the same time. So we're just going to use a standard Podman build, right, on a container file that I have in current directory. Clearly, it was cached because I don't trust the demo gods that much. But basically, right, we have just suddenly built ourselves a brand new container. Let's go ahead and take a quick look at the container file we used. And Ben, you might want to backstop me here a little bit on this, but this doesn't. It looks mostly like a regular container file, right? We've got our from, which is a little bit different because we're using the new bootc images. We've got typical DNF commands and system commands and things that you use during a run. But we're missing a few things here around things you might normally see in a container to make it work. Around there's no entry points. There's no commands to run, right? Things like exposing network ports don't really make sense here because we're not. Well, we built a container. We're not really going to run it as a container, right? It's going to be run eventually here as a full virtual machine. So let's go ahead and quickly push this.
Yeah, it's a great point that our target, is actually like a VM, like you said. But if we did include entry point, exposing ports, those would still work. If you ran it as a container, those would work as you would expect. But once we actually write it to disk and boot it, they would be ignored, right? So you saw that one line where system control enable, got to plug systemd, right? That is something you probably wouldn't put in most application containers, but since our target, like Matt said, is a VM, it now that stuff actually really does make a lot of sense. Sorry, back to you, Matt.
Yeah, no, that's great because I was trying to get the VM to actually start. So, like we said, right, this is a VM. So let's go ahead and kickstart a VM, and let me get in there in the 60-second time window I gave myself, and hope that I type this correctly, right? So we have or we will, because I just realized I need to go back and start the web server. But basically, we're just going to go ahead and again on that build host, I have or will have a web server that is going to serve up a sample kickstart file. And we will not hit enter because that will fail until I go back and do this. And I'm just going to cheat and use the built-in module. Cool. And we're going to get this up and running, and then we'll talk about exactly what it's doing because this is going to take about 2 or so minutes to bake. So we'll let this run. We'll watch this in the background if we care to. So yeah, we just kickstarted a virtual machine on my laptop. This is all running locally in Cockpit. So is the build machine running locally. And what it's doing, I can't stop that yet because
do we have a poll button, Eric? Because I'd love to poll the attendees to see if anybody's head exploded that we just kickstarted a container to deploy it.
I wish we had the ability to poll, but if put your reactions in chat, and we'll see how many people's brains just broke, or we may have just broke the internet. I'm not sure, but yeah, I mean, we took what, about a 6-line container file that we built just from the container file. You could obviously use tools like Podman and Builda to build a specific image, and we'll talk about bootc here in a minute. But Matt, there's a request to see the Kickstart file if we could as well.
I was just about to do that now that it's actually started kickstarting. I didn't want to cut off the, I was about to go back and cut off the Python HTTP module before it actually picked it up, and that would have been bad for the demo. So the standard KS config that we've got here, right, looks very much and should be very familiar. I'm not going to go through the whole thing. I really just kind of want to highlight these 2 lines. The thing that majorly differentiates this from a standard Kickstart file you currently know and use is that there's no packages block. We're not installing software this way. Right? Instead, what we're doing is we've got a new command available in Kickstarts through Anaconda that actually will go out and pull down that container file that I just built and unpack and lay down those bits directly from that image inside that container directly onto the disk. Right? And that's our software install. After that, though, we move right back to standard Kickstart install things, right? Ben actually built this Kickstart file, so he's got some firewall things going on. He's making sure SSH is installed, a user setup, all the typical things that you would want to do when you're kickstarting things. The only thing that changes ergonomically from a standard Kickstart is what the source is for the software.
Yeah, and actually to add a little color. Well, one, I have to confess, I mostly copied and pasted that. But two, so what is, if we think about a container image, right? It's just a tarball with files, right? So we have that RPM transaction and anything else we've injected into that container image, but there's no disk image. So how do I boot that? Well, I can't just DD a container file down. I have to actually do something else. So you'll notice that Kickstart is going to prep the disk. So any kind of partitioning, any type of disk layout, we can rely on Anaconda to do that, like always. We can configure users, so things that need to live in that deployment. The post section, if we want to run commands, we can do that as well. But then the entire OS really just comes out of that container image. So it's a cool way. And of course, we have other ways which we'll show how we can do the same for Image Builder to actually build that disk image as well.
I just keep darting to the clock to see whether or not we are at, and we have. It has already caught the reboot. So let me go ahead and finish our little proof of life here. First off, I need to go back and get to the IP address for our brand new VM. And then Ben set up this core user. It has a super secret, very secure password that I will not share. But let's see. All right, so we have a virtual machine. I think, Ben, in order to really show people that this is proof of life, that we have a bootc image running on this particular virtual machine, I'm going to show the status, and I want to talk a little bit about what we're looking at here from that booted block. And I can highlight bits and pieces as we're going through here. So this here is telling us, right, that we have in fact booted this image off of Quay that we just should, well, you saw the cache build, but that we built and pushed, right? We've got a couple of different things when we're looking at the digest and the image. The tag and the SHA that are here is how a bootc instanced bootc machine actually understands whether or not there's updates available, how it attracts what it should and shouldn't be doing when it's pulling from a registry, when we need to update software, when we need to make changes to a machine. We go back to the beginning, right? We make changes in the container file, push them to the Quay, and then an update would be available on the host. Right, so I think we've got proof of life, and we've got, I think one thing we're running here is we've got we've got a PHP info page that I can't show because I don't have a browser on the terminal. I should have piped something. I should have dumped that into something I could have just shown you at the top of the line. But,
does Link still exist? Is that still a thing?
It probably did, but we didn't install it on the image. Yeah, I mean, I don't really want to go back and we could do that. That could be the lot of that, but I think we'll stick with what we've got so far. So that was a grand total of 2.5 minutes, mostly because the build and the push are pre-canned. But I did some timing this morning just to be able to to talk about it, right? So this is a pretty small, pretty standard image, right? I think we're under about a gig and a half with this particular one. Take about 45 seconds to a minute to actually do the build process, and then the push to query takes about 2 minutes, and then 2.5 minutes to actually do the kickstart the slow way I did it. So you're talking from scratch. This really, like, we could have sat here for 5 minutes and tap danced, and that's really all it takes to get a small up and running version of a bootc virtual machine that you can play around with.
Yeah, and then one thing we should probably just point out is, just like on application containers, you build a base or whatever incremental image you want to use, and then your next thing is going to be from the previous, right? And there's exceptions, but oftentimes the layers you build, for the most part, they can get smaller, and there's smaller differences as you go. So you that same methodology all applies here. So if we talk about just injecting different applications or different configurations, just depending on how you want to outline your environment, you'll pick up a lot of efficiencies as you go, which is pretty cool.
Yeah.
Well, if you think about your build environments, you could do all this on either a high-powered workstation, which we'll talk about here in a few minutes, or even on a server running in a virtual machine, or on bare metal. And then you were talking about layering. I'm thinking like standard operating environments where you've got a base image, and then you can just add layers on top of that. How small your boot environment, or how small your build environment is going to be, because you build that enterprise standard image that will have all your security tools, have all of your users, have all of your configurations, and then you build workloads on top of that. So the image size between, say, a golden Nginx server versus a golden MySQL server is going to be very, very small, because it'll just be that bottom or that top layer or two that'll be different.
Yeah, the caching that we saw during that build, like that wasn't anything fancy I did. That's just built-in caching, because I didn't change any of the layers for this morning when I built it clean, right? So these aren't demo tricks. I'm just relying on the functionality built into container builds to kind of make it take 14 seconds instead of 40.
But that was slick and easy. I mean, it wasn't a lot of lifting, right? I mean,
so let's talk a little bit about still kind of jumping around here a little bit. Let's talk about bootc a little bit, because one of the questions that I still had was between, we have UBI, which is basically a containerized version of RHEL, but this is different. This is a bootc image. Bootc is kind of the magic that makes this happen. UBI is a containerized RHEL, whereas this image mode is more of RHEL in a container. So can we talk a little bit about bootc?
Yeah, I think maybe let's talk about it like at the image level itself. One way you can think about like the RHEL bootc image versus UBI is, we're including all the stuff that we told you to not put in container images for the past 10 years, right? That's
like hardware drivers, for instance.
Exactly, like a kernel and a init system, all the things. Another thing that's worth understanding is that you can't just take a UBI image, or name your favorite, Alpine or whatever else, install a kernel, and then have it work with bootc. We are using some magic glue in the base image that's around bootc. Technologies like OS tree are in play here. There's also a newer technology called ComposeFS that's going to become a bigger part of the story over the next few months. But there's a little bit of magic to where you have to use the bootc base image. So just keep that in mind if you're experimenting. Let me save you the pain. It doesn't work if you try to make your own base image.
Matt, did you want to build on that at all?
Yeah, I think one of the the things that we'll talk about later, probably a little bit more detail, but building on top of sort of an existing base that like Colin did with starting with all the lessons they learned from Atomic through CoreOS. Micah, I see Micah in chat. He can go into great detail for us in comments if we want him to. All the lessons learned from years of doing this sort of transactionally updated image-based delivery system, even if it wasn't necessarily for a sort of a general purpose operating system like we're targeting with image mode for RHEL. We also get things, and like I said, we briefly touched on when I installed it that we're tracking tags, but that also means we can change between different things very quickly. So if we're in dev, right, and we got a new version of PHP that backs our app, available in 9.4, but how would you normally go about making that available to developers? Kind of a pain, right? And we could probably spend that entire episode just on how we try to do that in sort of the traditional package mode environments. With something like this, we could spin up a new container file, make that one change, spin up a new image, tag it differently, and then just take one of our existing dev servers and switch into the new image. And if it didn't work, we could just roll back to the previous image and start doing A/B testing with the developers on 9. Oh, I just lost. It was 8.2 and 8.3, I think, are the current PHP versions. And we could A/B test and flip back and forth and figure out where the changes are that we're breaking changes in PHP without needing to spin up entire parallel environments, right? So there's a lot of interesting things that we get to do with rollbacks and those sorts of updates that also make this a very useful and interesting way to go about not just giving yourself some safety, but also giving yourself some new flexibility that you might not be able to have it quite as easily.
So this was just announced at Red Hat Summit, which at the time of recording was about 3 weeks ago. My goodness. It seems like forever ago. I don't know about you guys, but
announced to great fanfare.
Yes, it was. It had a spot on the main stage and everything. So what features are available now, and sort of what direction are we heading in? What's the ultimate goal?
Yeah, I guess a couple things. So one, what you're seeing here is what we consider a technology preview. So it's available. It works incredibly well. We don't consider it GA quite yet, but we are pushing to make that happen as quickly as humanly possible. Let's see. You asked what was coming in the future. Sorry.
No, you're fine.
Drawing a blank. Okay. So obviously the next step, right, is to getting to getting to where it's declared GA and stable. There's a certain amount of API work that has to be in place before that happens, and so that's a big part of the immediate push. I will say, looking forward, I mentioned ComposeFS earlier. This is a technology that came out of our work in the automotive space. And ComposeFS gives us a lot of really cool low-level capabilities to make that bulletproof operating system. Just a few of them is, we've long time had requests for DM Verity type capabilities. And ComposeFS uses something called FS Verity, like we get out of the Android world. And so we get all kinds of boot time, runtime, just integrity checking. We can actually use ComposeFS as a backend for Podman as well as the underlying host operating system. So there's a whole bunch of efficiencies to be gained there. So it's just a really cool security story in terms of just signing and validating and getting that tamper-proof, like a much higher level. What we have today is good, but it's going to go from good to great with that. So I'm super excited about that. I guess there's a slew of things. Actually, I don't have my notes for what's coming in the next few months, so we'll just have to come back and do more as we go down go down that road. But there's a number of things. Compose FS is probably to me, that's like the coolest part.
There's just so many different pieces that came together, and so many different parts of Red Hat that went into building this. I mean, years of development and learning about things like Image Builder, Compose FS, RPM OS tree based images, which I'm not sure if the audience caught that or not. But this is for this is more geared towards RPM OS tree, basically non-transactional operating systems versus the transactional RPM base that we normally think of when we think of an operating system.
Oh yeah, actually, and you made me remember the other thing I was going to say is that, like, in terms of where we're going with RHEL, is it's one operating system with two modes. You have package mode, which we know and love is DNF RPM systems, and we have image mode, which is basically the bootc model that we've been talking about here. So I think it makes it really easy to just understand directionally where we want to go and be able to appeal to different deployment styles and footprints depending on somebody's use case, right?
So Matt, you had a lot of thoughts on image mode and upstream.
Yeah, so it is like Ben said, right? Like we're in tech preview, right? In the RHEL land, like this is brand new. We need people to help us flesh out what is this going to look like, right? We have the core basics are there, so you can use it, right? You can attempt to use this in anger and tell us where the sharp edges are that we don't already know about. But like everything we do, this is all, they started upstream. The bootc code itself, Colin started at least a year ago, if not longer. But the official Fedora community initiative, that's probably less than 3 weeks old at this point in time. So one of the other things we want to make sure that goes on, and we've already had some interest in other outside communities in the for a silver blue space on what other community projects and community initiatives can work with us upstream to polish off some of the rough edges, address some other use cases that we're not necessarily looking at. So, one of the other things that I think is always vitally important is making sure that we do get that good Fedora traction, right? And CentOS Stream is where a lot of this stuff was being worked on internally, right? We were doing stuff in Stream earlier in the year and late last year to make sure that we could test things before we even had internal beta access, right? So, getting folks aware, right, that at this point that the Fedora community is trying to form good plans around what to do with bootc and how that's going to influence projects is also something that they can participate in should they want to.
I've been watching the flurry of activity in the Fedora community around bootc, and I believe there's going to be a SIG formed around it. But there's a flurry of activity, and it's been fun over the last couple of months to watch this go from just an idea done in very much a Red Hat engineering way of, I wonder if we could build a thing, and then going, oh snap, we built a thing. We need help.
Actually, it didn't start with, can we build a thing? This actually grew out of our experience with OpenShift, right? And how customers basically, I think the quote, I'm not going to get this exactly right, but so the idea with OpenShift is that the underlying host is transparent to the cluster, right? It's just a thing that is managed at the kube layer. But one of our customers said, I love this, but I kind of need Red Hat outside of my operations loop, and I need a way to do these customizations. And so that is actually the spark of where, well, if we're already managing everything as containers on the platform, if I can just layer on the things I need on the RHEL Core OS nodes, that actually makes a heck of a lot of sense. That if you look at where we're going with OpenShift virtualization and KubeVirt, right, where it's one platform for containers and VMs, wouldn't it be great if we just used containers to make the VMs? Okay, great. Like it just connects the dots on across everything. So I don't know, kind of a cool story, but yeah, actually this was customer inspired, or the inception of it was, for sure.
That's awesome. So before we've got, I want to talk about Podman Desktop, but there's been a couple of questions come in, and first a comment from Will talking about that it's cool that Red Hat took a customer idea and embraced it, and definitely, I mean, if it's not one of our engineers or someone in the upstream going, I wonder if we could do a thing. Usually, a customer going, I have this use case, and their engineers and our engineers kind of sitting down and talking. But it's really fun to watch as these things develop, and with our dedication to CentOS Stream and with our upstream community and Fedora, it's really easy to see how to go about building something like image mode. So I want to throw you both in the hot seat here. There's a couple of questions, very use case centric. So um, let's see if we can't stump the chump a little bit. First off, Robert asks, how would this look deployed to bare metal at scale? Would you need a unique image for each server? Say these servers are statically IP'd, named, and say joined to an OU. How does this work on bare metal at scale? Is the crux of the question.
Yeah, it works the same way as in cloud at scale, except that how we do things is going to be slightly different. And so there's always going to be per instance state things that you need, right? Like you hit a bunch on IP address and so forth. And so basically, I think probably the most common way people are going to deploy this on bare metal is using Kickstart, like Matt just showed, whether it's Pixie or HTTP boots. That type of deployment model is far and away the standard. And a lot of times people, you have to pay the piper at some point with like, how do you do IP assigning, right? If you're not doing DHCP or reservations on an IPAM, you are keying those in somewhere, right? And so we can easily put all of that config data in Kickstarts and just have a unique Kickstart per system is one way to do it. And that way the entire OS image is one thing, but we just have the unique per machine things abstracted in a Kickstart. Let's look at cloud. We would take basically that same approach, but we would do the per machine unique things using cloud in it, right? And so that's one way to think about. There's the whole image, the container image, and then there's what actually has to live in my instance once it's deployed. And those types of things, I think, Cloud Init and Kickstart really cover 90%. Or, you could have you could call into something like Ansible to go fill in those gaps after it's deployed. So there's a kind of a bunch of good paths there, but those are, hopefully that clears it up for you. It's a good question.
Yeah. I think one of the things that helped me, right, is I don't know, this is a weird metaphor, so take it for what it is, but this feels like it's like phase changes in physics, right? Like when you're dealing with a container, like it's liquid, right? Like you can do pretty much whatever you want to it, as long as it's in the you're in the container space, right? Like you can modify it like we did with directly with a container file. You can run Ansible against the container and modify it that way. And it's not until you actually do what we did here and kickstart it and turn it into a machine that it sort of freezes. Yeah. And even when it's, in its image based operating mode as a virtual machine or bare metal or cloud instance or however you want to deploy it, things like Etsy, that's still machine state, right? So that's what Ben's talking about with how you configure these things. It's going to be stuff that writes to Etsy, and that's the personality of the box, just like it would be in a package mode system. Things like var are still available for logs and anything that's specifically machine state, right? So that there's a little bit to wrap your head around when you're trying to get this first deployed and get your process of where changes need to be made based on sort of what happens and what freezes when you actually go ahead and turn this into a running machine. But yeah, we're not losing anything as far as the standard things we need to modify when we want to make a machine and actually have it function.
Yeah. So 99% of the time, please don't make images that are machine specific. But if you have a good use case where it makes sense, by all means, you can totally do that.
Okay, so our next question is a little bit more future looking. Micah talks about, what about support for FIPS compliance, OpenSCAP remediation? How would that factor into this process?
Yeah, Mike has got my back. We should probably just pull him into the stream right now. But anyway, yeah, those are things like on the road to GA. Like FIPS today, like we can make it work on Anaconda side, but we don't have it plumbed through the image builder path quite yet. So that's something that will be in place for GA. And the compliance side, we just started the spikes to get the SCAP remediation going. But there's more work that we need to do on our side. I can't promise SCAP remediations for GA, but it's definitely something important that we're looking at right now.
Awesome. And then one other one, and I think we've kind of discussed this with the last question, but Kevin asks, where do changes live on the system in between image versions, such as security agent updates that's managed by a different team?
Yeah, I don't know, Matt, do you want to take this one, or do you want me to? I'm happy to.
Yeah, because I can give my favorite answer that hopefully Billy Holmes in chat will say along with me at home is it depends. So part of that is going to be, what is that agent, right? Is the agent something that is storing its own configs locally in var, and then it's cool, like, right, you install it into opt, it saves its local state that people are pushing things to, right? If your security team has like a console that they're pushing and managing all these nodes and workers to, and they're storing things in var, awesome. If it's something else that possibly some security minded folks that I used to work with would want configurations frozen as part of the container image, right? So that things are immutable to a certain degree, and they can't be updated by any outside force unless you actually update the host. In that case, you could work with the security team to embed them in the container as part of the container config, and that would be your machine definition, right? Because harkening back all the way to what Ben said earlier about layering, right? If you think about it, each set of layers you can build is sort of a set of core capabilities, right? So you have the base thing that we provide you, and then you can stack on your admin tools, and then you can stack on security tools, and each one of those gets a little bit smaller and a little more specialized and provide places, if you really need to sort of fork, right? So you can say, oh, this is security tools X that are only for a particular environment. You could have a whole thread of things that are environment specific if you really need to, like driver support. You don't have your VMware drivers in your AWS AMIs because you don't have to carry everything. You just have a single package and a layer, and that's perfectly acceptable.
Yeah.
Well, and I think I think it'll be interesting to see how the tool develops around questions like this. If different teams are managing that standard image, that's going to start to trickle downstream within the enterprise. Looking at containers and pipelines, you can have projects that are set up. I mean, as a former GitLab person, I'm thinking, my brain is picturing the GitLab CI interface, and there's built-in container registry there, and just building a pipeline that says, if the upstream base image updates, update my image and redeploy. This is like taking the pets versus cattle conversation and blowing it way out of the water to the point where the security team goes through the CI process, basically using Agile and DevOps, and talking about how security team comes in, they run their check, they push their changes to the base image, and then how that affects downstream. You can really start to focus more on workloads and automating those than you do having to maintain all of those systems by hand. So, Ben, I know you're excited to talk about Podman, but there's a little bit of shenanigans going on this morning before the episode went live. So I want to kick it back over to Matt before we talk about Podman Desktop.
Yeah, so Ben doesn't know this happened. So we're gonna get Ben's reactions live on stream to see what he thinks about. So one of the things I've been playing with, and this is a private repo with some old stuff. So this is actually this is brute force. This is just a proof of concept to show folks that what Eric was just talking about with CI and with these sorts of things are real, and they're not things that we are just sort of playing around with. So this morning I taught myself Docker or GitHub Actions in a very bad way. So what I'm going to show here, and what Ben is going to hopefully enjoy, is what I've got is an action, and I got to figure out how to show it. It's this one. So what this does is this is just a standard off-the-shelf marketplace, I think they call them, GitHub Action, that uses Docker's buildx environment. It installs cosign. It does all of these various different mechanisms and things. And eventually when it spits back out, it comes over here and it pushes to my own private GCR repo and builds me this image. And it's pretty easy to trigger. So let me go ahead, and I realized that I forgot to change the name of this particular workflow. So let's go ahead and do that live. And we can actually have it kick off and see whether or not I actually managed to build this correctly. So let's go ahead and just change that to, let's see, with GHA. Get those changes, and because this is brute force, any change in the repo will rebuild a particularly singular file because it's a very sophisticated thing I figured out how to do today. And let's click the logs real quick. And yeah, it is screaming along. It's going too fast. So we've gone ahead. We've managed to get a builder up and running. We've got cosign installed, so we can assign it later. And it is currently in the process of setting up a Docker buildx, right? This is, like I said, this is straight out of the marketplace. So this is not Podman. This isn't even our tooling. I don't even know. I think this might be running an Ubuntu runner. I don't even know at this point in time. I just copy and pasted and changed a few things to make it work.
Everything you're not supposed to do.
Everything you're not supposed to do. And because, again, this is it's a simple change to an external file. It didn't actually change the contents of the container image. It builds pretty quick, right? So we have a successfully signed and published brand new version of our package in the I gotta go to code, right? Yeah, so we now have a brand new package. It has recently published this new image that is available. Were I to make this public and actually be able to log into it, container that I could download that I built. And this is all I'm using an older bit of CentOS Stream 9 multi-stage build, right? So even the build itself is it's a multi-stage calling from in one big giant file. So we're not just trying to target Podman and Podman Desktop. Those are our tools. Those are the things we know and love. But the entire point is that you're supposed to be able to do this with anything that knows how to do CI and anything that knows how to build containers, because they're, as much as there's fancy stuff in the container, the box around it, right? The actual shipping container in the metaphor and the manifest, that's standard. It'll work in any registry. It'll work with any build tools. All you really need, and this is why I did it with the CentOS Stream, is access to the bits. And I didn't want to figure out this morning before 1 o'clock local how to set up a RHEL system to try to do this as a remote runner. So Ben, there you go. Secret demo of a GitHub action in a bootc build. What do you think?
I think it's awesome. Should we talk about what happens on the client side?
Yeah, go for it.
So check this out. We made a choice in the base image. It's of course userable. That's not a word. User configurable. But by default, whatever repo you deploy your system from, we're going to watch that for updates. And when there's an update, we're going to apply it. So if you never update your container, that host is never going to update. The flip side is like Matt just showed, anytime we make a change to a file or trigger the runner to do the build, when that hits the registry, your system will see that and then apply that update, which is pretty awesome, like pretty powerful, particularly if you're managing a bunch of boxes. Now, in the real world, we do expect people to say, my update window is, Sunday at 1 a.m. or, whatever makes sense. So please, it's a systemd timer. So please change that to something appropriate for your environment, or disable it if you want to just manually always do the push. Super easy to do. It's in the docs, but that is a pretty cool, I think, default position to take in this space. Nice job with the Rogue demo.
Yeah, he asked if we could squeeze it in, and I was like, I am all for surprise guests and Skunks Works demos, all kinds of fun. Ben, I gotta blame you, buddy. It's you came up with like the sunglasses and the Rogue intro bumper, so we had to do something.
No, this is great.
So one of the things that really appeals to me about this operating system in a container concept, is a Linux enthusiast, but also as a former systems administrator, is that I have a very powerful laptop here. I've got I'm itching for my framework laptop to come in for my Linux side, but right now I'm looking at a MacBook M3, and I go to conferences, or sometimes I'm sitting at the ball field waiting on my youngest to stop playing in the dirt, aka playing t-ball. And I use that as an opportunity to read or do research. But if I were a sysadmin today, I could imagine using that time to work on our standard image build. And one of the nice things is I've name dropped it a few times, but Podman Desktop will allow us to use this process, and we've built a lot of concepts of image mode around this idea of using Podman Desktop. So Ben, for folks that haven't interacted with Podman Desktop, could you give us the quick 30-second elevator pitch as to what it is, and then let's dive in on how to use it?
Yeah, just in the simplest term, it's a really nice UI. It's cross-platform, so you can run Podman Desktop on, Mac, Windows, and Linux, and basically it gives you a really, really nice developer, interface experience that we've expanded. Not only, originally it started with just the core, Podman kind of fundamentals, and we made it to where it's actually really easy to take applications and move them over to OpenShift and generate all the kubeyaml, everything you would need. Then we made it, it's actually like really easy to run OpenShift in Podman Desktop. And this year at Summit, two of the big things we did related to Podman Desktop is we have a new thing called AI Lab, which is a little bit out of scope for today's thing, but you should totally install it and look at it. And then
that episode is coming.
Yeah, the thing that is in scope is the bootc plugin that I'll show you here in a second, which is super cool. Super cool is the official term here. Okay, but yeah, this is Podman Desktop, and all the basic concepts you're familiar with on Podman are here. I'm going to kick off a build, and yes, for time and other things, yes, this is already cached, but because who wants to actually watch this build from scratch? That's not fun. But I have a simple container file. Actually, it'd probably be too big of a pain with the screen share to show you this file. All it says is from the bootc image, add Etsy and add user. So here's my Etsy and here's user, and all we're just going to do is drop those files on it. That's all it does. And actually, we'll just really quick for fun, all this is going to do is add quadlets, which is I think, the coolest way to actually define Podman containers on a RHEL system. This is going to give us a WordPress instance. Yes, I stole a lot of this from Major Hayden. If you follow his blog post, thank you, Major, for the work. And we're basically just going to drop that onto a system that'll boot and fire the whole thing up. And it's super, super simple. So I passed Podman desktop the container file. It knows the context directory. I've found it helpful to just mark these containers -bootc. You don't have to do that, obviously. But let me show you something interesting here. Of course, this is a Mac I'm running on. And so it is an ARM powered system. But in the real world, most things get deployed on Intel. I shouldn't say in the real world, but the amount of Intel out there is staggering, right? And so we could actually build for multi-arch with one click. Pretty cool. But since my bare metal box I have here is a small little OnLogic CL250, which is awesome, I'm going to build this bootable container for x86. And this is just going to fly by because it's already built. So were you amazed at the speed? It was already on disk. But honestly, even if it wasn't cached, it's actually super fast, even with the user emulation, to just copy some files over. If you're installing RPM, you'll notice a speed hit. If you're doing compilations, you'll definitely feel a speed hit when you go multi-arch. But so now I've used Podman Desktop to do this, and this guy right here is the bootc plugin. And let's go ahead, and this is the x86 one I just built. So we'll select that, and I could do multiple outputs, or I could just do one. I think maybe just for fun, I'll do a QCow. Again, you will have to match the architectures and stuff. Oh, I got to give it an output folder. We'll just use my home directory because I'm a slob. And we can see the progress here. And this will take about 3 minutes. It's not a super long process. And that'll give me a QCow I could boot. And then from there, again, this is actually one of the things that I think it's worth probably elaborating on is when we're talking about bootable containers, when you first deploy, there is a process of, like Matt showed, when you kickstart a box, or if I need a VM image where I'm actually doing the conversion here to a disk. Once you get this thing on disk, once it's deployed, once it's running live, that process of doing that conversion is totally out of the picture. We go straight from the registry, straight to that running VM or bare metal box. So the loop is super fast and it's very, very lean. So you only have to do the kickstart or the image, give me a QCow. You only do that one time, right, when you deploy, and then from there it's really fast. One other thing I wanted to show, which is nice, if you install Podman Desktop, which again, I think this is probably the easiest way to just kick the tires and get a feel for this. I'll minimize that. We have a Red Hat extension pack, which will, it'll prompt you if you have a developer subscription or any kind of Red Hat login, you can just drop that in there. And then this handles not only authenticating with registry.redhat.io, because you do have to auth to that. And then it will handle the subscription manager part inside the VM, because if you run on a Mac, you're actually running inside of a Linux VM. Specifically, it's Fedora CoreOS. But we handle the subscription manager part there. And so anything you build with bootc and do like you want to add something with DNF install, all that stuff will just work. It's totally seamless. It's absolutely beautiful how it all comes together. And so, yeah, just grab that pack. You can add the bootc extension as well. And then that's basically it. Yeah, give it another, 30 seconds and this will just be done. But yeah, So that was what I wanted to show on Podman Desktop. Very userable.
Userable. I love it. So we covered a ton of ground here today, and we are at the top of the hour. But we did promise a first look, and so that's what we did. So I feel good about this. But there's just so many applications, so many use cases for this. In fact, even just working the booth at Red Hat Summit, people were coming up and saying, "Man, what if I could use this as to build out images for EMR, electronic medical record stations, so that nurses can go and log in? Or what if I use this in my factory?" Just all these different ideas came pouring out of folks that had just seen the keynote or
it just completed the Q cow. Sorry to interrupt.
Yeah, no, you're fine. You're fine.
No, you don't need to switch back. I just wanted to
see it worked.
Yeah.
So I mean, there's just so much going on. But Ben, Matt, we'll definitely have to bring you all back at a future date to talk about more use cases and new features as they come available.
We would love to come back anytime.
I'll have to hang on to your rock and roll intro bumper. But as we wrap, Matt, I'll throw this to you. Any closing thoughts? Anything you want to part with? Anything you want to share with our audience?
Yeah, I think the most important thing, right, is typically we don't talk about things in tech preview, right? First rule of tech preview: don't talk about tech preview. We're breaking the rules. We want to talk about tech preview. We want to talk about upstream. We want to talk about y'all trying this, and we know it's functional. What we want is more people to actually help and figure out, more people who have those use cases. They're like, oh, I want to try it to do X or to do Y, and see where we need some help, where we need some work, and find better places to use it. So we want people to get involved, both with the upstream and with Red Hat directly. So please come help, join us.
Yeah. Well, and Ben, you're not off the hook just yet. So we had a question come in. So I want to address that before I get your closing thoughts. So you mentioned the Red Hat extension for Podman Desktop. Is that pre-filling RHSM credentials on the built image? How does that work?
No, it's not doing that. It's basically a pass-through on the underlying. So the subscription manager part lives in the underlying VM, and then your registries will just work, and it'll pass through the auth. So your image won't eat up a registration. Now, I will say we have an examples repo with a bunch of cool ways to shortcut building your own container files. And in there, we do have an auto-reg one to get your instances to call into Insights. We should also talk about something that's there today is Insights support for bootc images. And that's super cool. Again, super cool is an official term now. Yeah.
Any closing thoughts? Anything you want to part our audience with? That's great English.
We've given them userable. I mean, no, I guess
writing this down because this is good stuff.
Yeah, I mean, this is pretty exciting stuff for us here at Red Hat. So one, we appreciate all you guys giving us the time and coming to see what's going on. As Matt said, we would love any type of feedback. We'd love to hear what works well, what doesn't work well, and make it better. We see this as basically a huge opportunity going forward with how. Just like the promise here is how we can actually simplify at a higher level a lot of what happens in IT. And that is actually pretty profound. That's the mission, the goal, and what we're after here. Because complexity is the enemy. And there's a lot that we can make easier with this method. So yeah, I appreciate everybody's time, and if there is future feedback, we are all available. Let's do this again. I promise to up the shtick next time. And yeah, that's all I got.
Awesome. Well, thank you all for joining us. If you're watching deferred, feel free to put your questions in as comments. We'll so Scott, McBrien, Nate Lager, and myself check those on a regular basis, and we can tag Matt and Ben in if we need to. So upcoming topics, we're definitely going to be keeping image mode on our radar. We're working on episodes around RHEL AI. Also looking at bringing the Podman desktop team back on. There's a lot of new extensions, not the least of which is the AI lab. So yes, there's AI coming to RHEL Presents as content, not as production. It's still all by hand, so I appreciate those of you that have helped us out with questions, and especially those that have been helping us out with answers. So this Friday we're back on a regular schedule. As Into the Terminal, we'll be back with Nate and Scott. We'll be talking about tips and tricks to help keep your sanity in Bash. And then RHEL Presents will be back in 2 weeks, although the topic is up in the air a little bit. We will be bringing Yubico on to talk about single sign-on and YubiKeys, but that episode, due to some scheduling issues, needed to be pushed out. So that one will be in a month. So I'm not sure what we're talking about in 2 weeks, but we'll put our heads together and we'll track down some guests. There's so much discussed.
We know it's going to be great.
Yes,
we know
it's going to be so great. But on behalf of my guests today, Matt and Ben, and on behalf of the entire Red Hat Enterprise Linux team, really appreciate your time and really appreciate you checking us out. Make sure to subscribe, share this channel and this content with a friend. The more folks that watch, the better our content becomes. So thank you all very much. Really appreciate it. And on behalf of Matt and Ben and the entire Red Hat Enterprise Linux team, I've been Eric the IT Guy Hendricks, and we'll see you all again soon.
Thanks, everybody.